Okay. Okay, I believe this is now working. I'll just double check to see if I can hear myself. Okay, I believe this is now working. I'll just double check. Yeah, everything seems to be fine. So, what I plan to do is I plan to stream me developing a game using Unity 3D. This is going to be a exercise of sorts where I'll set up my own rules and I'll try to make a game based off that. So the rules will be that I'm only allowed to use Unity documentation. I can't go on YouTube, watch any videos, look for some answers. I'm not allowed to see the code. The only thing that I'll allow myself to use is this page here and anything that's here. So, but besides that, nothing else will be allowed. Now, secondly, there will be no working on this off stream. So I'll only work on this game on stream. I'll not plan when the stream goes away. I'll not test code to see if it works or not. I want it to be realistic and organic. So if there's a problem that I'm not 100% sure on, I'll show how I worked on that problem to solve it, or if I completely abandoned this problem and chose to solve it in an alternative way to recreate the organic workflow of programming the game from the start to finish. And I'm not going to use any external assets. So this is something that you could do yourself by either replicating me or seeing my workings through. I might use things like tmplow or ShareDiagraph, which can be downloaded straight from um, where we have the package manager, but nothing apart from package manager. And if anything, I'll only use the basic elements of package manager. So what I'll be making is a tower defense game for this, and I guess it's time to start. I hope the quality is good. Let's just have a look. The text seems visible enough. Yeah, let's give this a go. So firstly, I'm going to start off by selecting creating a folder structure. So we'll have our resources folder, I guess our scripts. Inside we'll have prefabs. And what else do we have? That should be it for now. So let's think about the things that I want to do in the game. So I guess the very first thing I want is a map. Then I want to have the enemy movement. And then we will want tower shooting enemies. And then we want to get an entire full round going. So let's have a quick think. So to make this very simple, I'm going to use a cube as for the map. I guess we can make a grid later out of it. So this will be called a tile, or tile is good. So we will actually disable the mesh on this. We will not need it. It's just going to be an empty tile. And inside, I will create a new cube. And actually, in the resources, we can create a new folder, and we're going to call it materials. Now, inside, we will create. I guess in a tower defense, you can click to create a tower on a specific land. So I'll discern this by having three. Let's open paint actually, just to show my ideas over. So let's imagine that we have a map. Now the map will consist of a path, and then it will have areas where we can build, which could be marked with green, and then areas where we're not allowed to place any maps. So those could be gray. So how we are going to represent that here is we'll have a buildable block, buildable, and then let's duplicate it 2 more times. And the second one's going to be the unavailable. Actually, available, unavailable makes more sense. Available. And then we will have the final one, which is going to be the path. Now, So the path slightly stands out. I'm going to make it a little bit smaller, I guess, than the other ones. And now let's give them all their individual color. So I'll right click create and I'll create a path. And then we'll have actually, we'll have the grass and then we'll have, let's call it dirt. I think it's better if we change it to that because available and unavailable could be used for something else, so the naming can get slightly confused, whereas this will directly refer to what kind of a block it is. So now select on the dirt block, attach dirt, to the path we'll attach the path, and to the grass we'll attach the grass. Here I'll just change the colors of each, so the path is going to be a gray color, I mean gray, brown, don't know my colors. The grass is going to be green, and finally I guess since we want the dirt to stand out, we're just gonna make it. Now let's just do it the other way around. The path is gonna be gray and the dirt is gonna be brown. There we go, like so. Now that we have our 3 blocks, we can disable all of them. So what will happen is when we place our block later on, we'll just have the one that we need enabled, like so. For now, I guess they don't do anything, but yeah. So what I'll do is, just to prepare for the system, I'll create a tile script and I will attach it to our block. Currently, I'm not going to play around with it at all because I just want to get the characters to start moving. So first, let's just create a very simple map. So I'll create an empty game object, reset it, and this will be our map object. We'll actually go into prefabs and make our tile a prefab. Drag it inside the map for now. And I'll just duplicate it and hold Control because that moves it exactly by 1. So for now, I'll just create a simple, I guess, 6x6 map. Well, how much is this? 5. No, it's like, so 10 by 10. Yeah, sure. So we have 10, 10, 10, 10, like so. Now, okay, this is good enough just to get the game going. Now, I kind of wanted not to have the stuff on the inside. Oh, I didn't select everything, did I? But that's fine. So what I'll do here is I'll open the prefab manager. I'll disable all of these guys. And now if we go back to the scene, we see that everything's disabled. And then we can individually set every block, although that's going to be very painful to do. Should have thought about this a little bit better before there's the glass block. We're going to make everything there you go. Just enable that. Go here. Okay, there we go. And now let's just pick some individual blocks and create our path. So we can make the path start in here. Just going to disable this and enable the path. Again, do the same here. Now this is probably the most tiresome aspect of this. Later I'll try to make it more manual, but for now it is what it is. Okay. There we go. How? What? Oh, I have 2 blocks in the same spot. That's interesting. Hello. Wait. What? Was I moving the... that's right. There we go. Like so. Again, path. Like so. And then I guess we can just go one more to the side. And then one. I could have just selected all of them at once, couldn't I? No. Why am I doing this? It's not gonna let me disable all the glass blocks without doing it the stupid way. Okay. So with this, we have a very simple level. And now we can start, go away block, we can start creating some movement for the characters. We'll have to actually do a little bit more in a bit with these tile blocks, but that's irrelevant. So for now, I'm just going to make an empty game object. I'll call it game manager. This will manage our round later on. And let's create our little enemy. So it's going to be a capsule. Is this? No. What? A cylinder. Wait, what's a cylinder? Oh. Why was capsule? Oh, maybe I created... Oh, I created the sphere by mistake. That makes sense. So let's just put it on a path, see how big it is. It looks slightly too big, so I'm going to reduce it in size by half. That looks a little bit... Actually, what if we make it... There we go. Now, let's just set up the camera while we're at it. Just give it a top-down view of sorts. Like so. How does it look? It looks alright. Now, I'll give this guy a color as well, and we'll change that to red. We'll just call it enemy. Now, our enemy will be red, just to show danger. And what the enemy will essentially do is he'll walk from one wanted point to another till he reaches the end. So that means that now every single one of these, I guess, should have a... So there are several ways in which we can handle pathfinding, but the way we will do it is we'll make it so that every tile has a little point above them, which is going to be a... I feel like this will ruin our path if I do it. So we'll edit the script. So this will be this first part. I'll add some code. Well, if you can call this coding. So I'll just remove the default everything, and I'll make a serializable field, which is going to be a private transform, and it will be, I guess, the path point. Now, what the path point will do is it will let us move the enemy by that specific point. So here I'll create a new empty object, and I'll call it path point. Like so. Now I'll drag the path point above, and real quick, just to see how it looks like above the path. Like so. Let's just create quickly a capsule, and let's make it the same size as the previous one so we can kind of tell what it's going to look like on the ground. So we ideally want it... Let's parent it real quick, and that's how much. So about 0.5 off should be fine. Yep. like so. And let's just remove that. And we will give this one of these guys. Now these show you like in the scene view what it looks like. So what will essentially happen is they will move from one to another. And now, actually, let's do it slightly differently. Let's follow the system that's serializable. Actually, let's just leave it like it is for now. No. Yeah, let's leave it for now. Why am I trying? There we go. And these guys, I made this yeah, of course. Now they're all back to the path blocks because I saved that. Why really? Okay. Well, it's okay. Doesn't matter. Okay. So now let's make a game manager script. Game manager. And what game manager will do is it will store our paths together. So actually, we'll just make a reference to all the tile blocks that hold the path. So private tile, and that's going to be a list, and it's going to be the path tiles. And then we'll have private transform the enemy path. So what this will do is this will allow us to assign our tiles in the inspector for now. Later we'll manual the system, and this will take the tile points from here, like so. First I need to make it accessible. I'll remove the set because we don't want it's unnecessary. We only need to get this point. So then what will happen is once we press start, we'll loop through every single path file, and what we'll do is we'll just do, actually before that we'll do, let's just make this a list for a convenience sake. Let's transform enemy's path, and then we'll, there we go. So what we'll do here is we'll enemy path dot add, and we'll do path tiles dot, and what did we call it? Path point. Wait. Why is this not available? Oh, that's right. Path point. So what will happen is for every single one of these, we will add one of that. And have I set them up though? That's the real question. So if you go here, no, I didn't. So now I go into the prefab, which is the tile point, and I assign this little path point into here. And what will happen now is now, actually, I'll make another thing. So I'll make this is going to be, so let's just make some comments. Source, the point for the path for enemies to move on. Now, private is path is equal to false. And then what we'll do here is a temporary variable set to true. False, then no, if set to true, path texture is applied on play. So what will happen here is I'll manually set the path, because every time we update the prefab, it will change everything automatically. So what we'll do here is on start, we'll just do, yeah. So instead of having everything start off as that, we will default everything to a block. However, if is path is equal to true, we will then do, we actually need something else. We need private transform, and then we'll have block types. So stores different types of tile blocks. Initialize, this is the correct tile visual, like so. So then we'll do block types. Actually, we'll do for block types dot let. That's right. We need to make an array first. So block types dot length. We'll just do block types I dot is a transform dot game object dot set active false. So we will disable them, every one of them, and then 0, 1, 2. And then what we will do at the end is we will enable the one we want to true, which is going to be the one at second position, which is the path, like so. So if we go here, open the plug points, we will drag in the grass, we will drag in the dirt, and we will drag in the path. And by default, everything is false. So if we go here, there we go. By default, we have the path manually without having to click on everything. And we still have our points, so everything should be fine. We could do something similar for the other one, and to avoid using numbers like these, we can actually use a new num, which is written like so. So if I type in, just make this a enum, and we'll call it types of blocks, and we will have a grass, dirt, and path. So then we can make a public enum types of block type, and what that does is it will assign our blocks. So what we'll do is equal to, actually leave it like this, and then on start, block type is going to be equal to blocks type of dirt. Or should we actually do it in here? Yeah, let's leave it in initialize. So no, grass. So by default, of all of our blocks will be grass, but of course once we run the code they'll change. So what actually happens here is, if we go, so this gives a name attached to a number. Technically this is what an array does. So a grass is a 0 in the array, dirt is 1, and path is 2. That's basically how it operates. So this is 0, there you go. If you overwrite, this is 2, right? So now here, instead of having 2, what I can just type in is path. Well, not path, block type. Oh. Wait, how do I actually write it? Yeah, I believe, and then all I have to do is just cast it as an integer. Yeah. So what this does is it converts this into an integer, because as we see, this is an enum, which stores a word, but we still know that that word corresponds to a number. So by casting this into 2, we'll be changing that into the number, but actually we haven't changed it into. So in here, if path is true, we'll just do block type is equal to dot path, like so. And if we just run this, we see that it looks like it's supposed to, because it's correct. No, it doesn't actually. No, we now need to, because we actually haven't selected the paths. So why did it not update the code? Wait. Now let's pick all of the blocks that I want to click on. Just these guys, these guys, these guys, these guys, these guys, these guys. These guys. Okay, now we'll enable the path on them. And what I'll also do is, and by default, we will want our block type to be set to. So I guess this will, let's just move this out of here and add this to our initialization. So at the start, we disable every single type of block, and we will set the block equal to the integer type. But then, yeah, let's just leave it at that for now. And now if we press play, it doesn't work as it's supposed to. Let me just. So compiler always complains, but if you just say everything to null, it'll stop doing it. That's because it doesn't understand what this means, which is weird. Okay. So let's see where we are getting a problem at this stage. We set it to a path. Now let's go into scene, click on it. Ah, that's right. If this path is equal to false, it's because we enabled both of them at the same time, so both of them were actually enabled. So else if, so this is what happens. So this sets all the blocks to invisible. Now, if the path is false, it turns them to grass. Else it makes them a path block, like so. There we go. Now, since we know from the start which, now we're going to manually assign for now our blocks to our map so we can start working on the code. So let's just add the game manager script here, open up the paths, and I'm going to lock it so I can now drag objects in without this screen disappearing. So I'll add them one by one. Now they have to be added in the correct order, because if they're not added in correct order, and the character will move incorrectly. Of course, there are numerous ways to fix it, but at this stage, we just want to go for the simplest approach, the one that requires the least amount of programming. Now, if we drag this across, and drag this across, this, and finally this. Now, with the map and the tile set, we can now start working on our AI. So let's just create some folders in here. We'll put map separately, or let's call it map generation. So anything that will be responsible for map will be here. Enemy will be here. So for the enemy, we'll create a script called enemy movement, and this will allow our enemy capsule to move around the map. So let's just rename it to enemy and drag it across here. Now with this, so our enemy will need to have a reference to the game manager. So we'll type in private game manager manager, and on the wake we'll do manager is equal to game object dot find. No, find. And we will type in game manager, or in actuality, let's just do it slightly differently. So in start, we'll make an awake function And let's just actually comment here. So this is the preset tiles with path, and this is going to be the stored path for the enemy. Now, actually, this doesn't have to be here. This can actually be cut for now. And let's just do public static game manager, and let's call it instance of the game manager script. Now, all I'll do is instance is equal to this. Now, this little cool thing is allows us to simply just do game manager dot instance dot and whatever we want to do. So here, instead of having that, we'll just do public void get path. So this will give the path to our enemy, and what get path will do is it will basically just do this. And let's just do, what do we have here? So we'll put a transform like this. So, and then we'll return. So let's just do, we had, oh, I removed that. So we'll just do transform, and then we'll call it, actually, this transform get path, or just call it enemy path, like so. Okay, so here we create this, and we'll actually just return this straight away. Change this to a list. Yeah, and so we have, so what this does is it grabs the path for newly spawned enemy. So in awake, we'll just call get path, and here we'll create our own list, transform path to travel. Okay, like so. And what we'll do is you can actually just make it an array. So what we'll do is we'll do path to travel is equal to, and we have a problem here because this is a different type. So we'll just do to array. So we just converted a list to an array, like so. So it grabs the path for movement. Now, this is unnecessary now. Path that the enemy has to travel. And then our enemy will have int, this is the position ID. Now, the way this section will work is if we just go back. So if we think of so since our map is basically a bunch of cubes, and I can't draw cubes very well. Now, all of them have a number on the array. So this is 0, 1, 2, 3. So when we're at 0, we are here. When we're at 1, we're here. When we're at 2, we're here. So what we'll do is when we start up, we'll always set our position to 0. And what we'll keep doing is moving it from one position to another in a smooth way over time. The current position ID based on the path to travel array, like so. Now, okay, let's have this. Let's remove anything we don't need. Now, what we also want to do is we want to spawn some guys in, but let's just do it with the one we have for now. Do we have the script attached? Yes, we do. So we'll create a new function called update. And what update will do is it will constantly check if we're at the right point. So what we'll do is this dot transform dot position, and we're going to be equal to alert, I guess, be vector3 dot alert. So what we'll do is we'll move it between our current position and no. So what we need a start position and end position for this to work. So let's quick give it a thing. So our yeah, and so it's going to be between two vector3. So we'll have a vector3 start pos and we'll have vector3 end position, like so. And what we're lerping through is like so and like so over time delta time, and then by a variable of speed, float speed, which we can set to 3 or however much it's going to be. So it'll be times dot delta time times speed. And let's see why we have some problems here. Unassigned variables. So now we have two unassigned variables. So when we start, our path to travel is 0. So start pos is going to be path to travel, and it's going to be at position ID. Transform the position, whereas end position is going to be +1. Okay, so this is where we start, this is where we finish, and now here we just need to do some quick checks. So if we also have to do some, because we don't want to keep running the same point. To put simply, let's run this through, actually, I think. So what should happen now is he should move, or what does he? Let's have a look at his position. No. Oh, why is the enemy? Oh, null reference. Oh, interesting. It's not grabbing our path. Okay. Is it because I'm trying to do all of this code before we get to the path, or is it something else that I don't see? Or is it the script execution? No, there should be no issues with script execution order. Is it because of the... No. Let's just change this to a... No. So... Clear the errors. Press play. Okay. So we're not properly getting the path. Now let's see if the game manager 100% has a path. It does have the path, and it has the tiles, which means this piece of code with .array is not working. Oh, can we just do it here? I mean, I don't see how that would work in any way, but let's just give it a try. Yeah, of course it doesn't work. Okay. Let's just abandon this idea temporarily, and let's just do this inside of the other one. So what I'll just do is in awake for the enemy, I'll just do, let's just do this for now. Game manager.instance. Did we right click on it? Yeah. Pathtiles dot length. And then what we will do is just do a list out of this. Like so. And that should work 100%. Boom, boom. Wait, no. We're looking for the specific point, path point. Is it because, wait a minute. Did this not work because, no, I was doing the path point. No, that was fine. Come on, should be okay. So path to travel should be that. Now press play again. Oh, shit, I didn't click play, clear and play. Why are you still struggling? It's the instance that's a problem. Really? That would be weird though. Come on, if that's the only problem, then I'll be sad. No, it's still not working. It's so weird. Oh, no, it is there. Wow, it was just a script execution order issue. Unbelievable. So we can go back to the previous solution. Like so. Yeah. I thought it could have been a script execution order. Well, okay. So something happened, as we see. So we've set up our start. Let's actually move all of this out of here for now. And try to get the alert to move between the first and the second point more fluidly. Oh, yeah. So let's move these guys out of here, like so. Let's remove the speed for now. Oh. Let's just do this the transform the position. Oh, what happened to the enemy? Okay. What am I doing wrong with lerping? Where is our lerp? See, I never use lerp. Never. Actually, I think I know why I'm doing it wrong. Look. Because what I'm really lacking is how I measure the time. Yeah, this is where I did it wrong. So what I really didn't do is I didn't really, because what I'm doing is I'm just adding time, but that should be done by uh, yeah, interpolated position, which is the ratio. So lerping is between um, a 0 or 1. So if I do it as 0.5f, actually we don't need an update for now. So let's just put all of that in start for now and change this to start post and then add a little bit here. So we're just going to go apply foot, we're going to put interp, and I'm just going to make it 0.5. And let's just make it serializable just to show what it actually does. So if we go like this and we go back to here. Now, as we see, where are we? Height. Oh, if we go into here, yeah. So he's moved along. Oh yeah, because he's in start. Keep this an update. Because then I can move it around. Okay, perfect. So if I slightly decrease it, it should move, but he's not moving. Why are you not moving? Oh, that's why you're not moving. Yeah. So there we go. So now he can move to the point and then back to the previous one. First point, second point, first point, second point, which is what we want. So like in the documentation here, what we kind of want to do is we want to count that so it happens over time. So if we look at some, yeah, there you go. We actually need a way to calculate the distance by calculating the journey length. So what I'm actually looking at is we're trying to do this in here. So let's have a look at it. So we need float the distance that we've covered, which is going to be done. Let's have a look. You need to float distance covered, and that's time away, taking away. What do they mean by start time? Oh, start time is just the time of when the motion has started. But then would that not be different for every single, every time? I guess it doesn't matter, to be honest. Oh. So what we really need is just to private. What's the float start time? And then I believe that was times by the journey. Was it correct? No? Times speed. Okay. So distance covered is going to calculate our journey's length. So we'll have another float, or is it? Yeah, it is a float, which is just going to be our, yeah, we're just going to use this journey length and we'll zero it by default. So let's have a look. What do we have here? Float distance. So what's going to happen is our journey length will always be determined by vector 3 dot distance, and that will, so when I said whenever it's going to be 0, 1, 1, that's what happens with the distance. So we measure the distance between our start position and our position to find the distance. And that's the journey length. And we can just add it here. Now what do we have? Move the target to the position. So we will have a second float here. Float fraction of journey. And we'll have this discovered by journey like so. And fraction of journey is what creates our interpolation number. Yep, so this should actually do the proper movement now this time. Let's just remove that. Denote position. Now the speed at which the enemy moves. Start time. And the fraction of the journey value between 0 and 1. Okay, let's see how well this works. Should work without a problem. Yeah, but now we kind of just skipped because start time is equal time dot total time, I believe. No, time, like so. But we're still not very smooth, are we? In fact, it's extremely unsmooth. Was because of the speed. Okay, so if this controls the movement of our character. Now, what we kind of need to change is this code needs to well, not this code. This needs to be reassigned every single time. So we'll do a private void change node, and we'll slap it in here. We'll call change node here, and we'll additionally call it if. So if this to transform the position dot no, it's vector free the distance, and then we'll do the transform the position, and then the second thing we'll put is the path to travel at our position ID, and then it's smaller than, I guess, 0.1f, then we need to make a call. So what we kind of want to do is we want to keep moving, but if the distance is smaller, we actually want to actually change the position ID by 1, and we want to run the change node code like so. Only once. There is no need to preset it more than once. Are there any journey length? Yeah. So everything should reset nicely, and the node should change. So this piece of code is an else actually. So this only works if the distance is not what we want it to be. +1. Okay, like so. So if we press play now, we should keep moving between every single one of the nodes. There is a slight bump at the end. Because of the distance being not as small as we wanted to. So we're just going to make it a little bit smaller. There you go. And now it looks very smooth. So now the enemy will keep moving from the start till the very end. We kind of want to boost the speed because this is taking too long. So what we'll do is we'll make this serializable field so we can manually adjust this. Like so. And now, so sets a new node for movement, and this controls, yeah, like so. Yeah, I didn't change the speed at all, did I? Now, there should be an error happening now. There we go. Now, that's because we have entered the, so basically, our position ID was now higher than, well, we asked for a position ID higher than the actual array. So if there is 8 nodes in an array, we can't ask for a position 10 because that's out of bounds. So what we actually need to do is check if it's not the last one. Because if it is the last one that we are currently on, then that means we've actually reached the end. So every time we plus, if then position ID is equal to or higher than, and that's going to be path to travel dot length. Wait, am I right? It's higher than, there you go, higher than or equal to. And then else we can just keep running our other code. So if it is higher, this is where we seize our movement for the character and we disable it. So what we'll just do here is we will actually just set this dot game object dot. So we'll just destroy it. Destroy this dot game object for now. So what happens here is we check the distance if the object is higher, is within this specified distance to the next node. Now add to travel to the next node, and then if the number of nodes, if the number of path ID is higher than the amount of nodes, destroy object, else continue, like so. Now, wait, yeah, I really need to increase the speed. Let's just do it something like this. And why did we not do it? Where do we get the call? What calls first? Ah. So this is all nice in here, but I feel like we're just calling this too many times. So that does. Let's just remove this check here, and we actually have to do +1, like so. Here, this is unnecessary. Necessary. Okay, let's give this a try. I mean, I know this will work, but my question is, are we not going to? I think we're going to have the nodes move way too early. So he'll disappear way before. Ah, it's all right. It's funny because it still runs the code. What actually should happen is it should return the code. It should not continue to the update. Let's try it one more time. Till there's no error. And it still calls the error. Okay. So I'll just make a simple check. Like so here. There you go. Just to get rid of the error. Which technically shouldn't happen, but what? If it's smaller. Oh, that's right. So if position +1 is smaller, then like so. Come on, speed up, boy. How is it still running the code? I don't understand. Why is index was outside the bounds? 954. It should have completely omitted this. Okay, so this adds. No, it's just smaller because equal than will still push it because it was equal, but it's actually an array which is -1 from the original value. And how do you still read that? Ah, it's so annoying. I know I'm not deleting it. Am I not deleting it fast enough? Is that it? Yes, because it's minus 1. That's right, because path.length is it's not the same as index number. Yeah, now it disappeared too early. So this is alright here. Or it will still give me errors. Yeah, there we go. So with this we have the complete movement. Now what we can do is now we can go into our prefabs and we can put our enemy in, like so, and we can now remove him from here. And here we will just create a, so we'll call this a temporary wave spawner, and we will make a serialized game object game object, and that's going to be our enemies. and we'll make also a private integer enemy amount. So what this will do is this will on start for each amount of enemies. Well, no. Actually, since we only have one enemy, we'll just do it the easier way. Enemies amount. So for the amount of enemies, we'll do instantiate, and we will do enemies I enemies, and then okay. So we'll cast this as a game object. Go as a game object. And what this does is spawns enemy 10 times. So what we have to do next is then go to transform the position, and we will set that as our path tile 0 because we want it in the first position. Transform, and we're just going to grab the path point dot transform dot position like so. So this will transform every object at the path point like so, and we'll do go dot name, and we'll just call him enemy for now, and that will have create 10 enemies, I believe, that will walk where we want them to. Now, as you see, we only see one. That's because they all spawn at the same time. So we need to slightly change this code. So what we'll do for now is we'll just do private void spawn enemy. And what we'll do is we'll move this. We'll actually let's have a private enumerator, and we'll call it spawn enemy, and we'll call this in here. But what we'll do is we'll do yield. What is it? Yield return wait for seconds. Yield return new wait for seconds, like so. Okay, and instead of having, so what we'll do here is we'll start coroutine spawn enemy, like so, and we'll add a new variable, the amount of enemies that spawn per wave, reference to enemy prefab, and finally private float a delay between spawn between spawning each enemy, like so, and we'll just put delay between spawning an enemy, and we'll just set it to 0.2f for now. Now controls spawning of the enemies, like so. Now there's some issues with that, mainly that they all spawn almost instantly, even though we have a delay. If we now change this to 1, I believe this problem will still persist. Yep. Now, it's a funny one. How do we yield? What am I doing wrong? Enumerator. So we only start the coroutine once. Actually, let's get rid of the yellow warnings real quick. Like so. So we instantiate See, I think the problem is with. So what? Let's do this. How to instantiate waver time? Oh, I know what we will do. So either way, let's keep away of tracking them. We'll need to keep track of the enemies, I believe, regardless of this. So let's just do it. List game object, no game object, enemies in wave is equal to new. Let's just do this real quick. So keep track of all spawned enemies. Now, first thing we're gonna do is we're gonna spawn in all the enemies in our coroutine, and we'll do go to transform the position and go to set active false, yield return, just to not have an error. So, and if we go here, that will be to, we'll change start to on enable, like so. So we basically spawn, create the object, give it position, we set it to nothing, we actually, and then we want to add it to our list of wave enemy system. So in wave.add, and we're gonna add go. So this will then let us calculate how many enemies we have in total, so we know how many there's left in the wave when they get spawned. And then let's just make a while loop. And what's going to be the condition for the while loop? So we'll set up an int set to currently active. We're going to set to 0 while currently active is smaller than enemy amount. So what we'll just do, you wait for seconds and 1. So we wait a second. Displacements. Currently, let's see if this actually works. So every second we should get a printout if this works properly. Actually, we can change that to the delay between waves instead of 1, which is set to 1 regardless. Oh, that's actually set to 0. Okay, let's have a look what this will do. Yeah, so our timer works, and what we'll basically do is here we'll just enable all of our enemies. So we'll do, let's just remove this. This is not necessary anymore. It can stay private. So where are we? Enemy wave at the currently active set active true. So every second we should get a new enemy pop up. And then it should just, if currently active is higher than enemies in wave dot count, then currently active is equal to enemies in wave count. That's just to prevent the code from breaking, which shouldn't happen because the while should end instantly after. There we go, and we have perfect spawns, and they disappear at the end, like so. Now, with this done, we now have the map and the enemy movement. So now let's just find a way of killing our little enemies. So what we're going to do now is we're going to create a tower. Now, I want the tower to fit on a single block as just like everything else. I'll just create a cube for now. Place it in the middle of the cylinder. And let's make it smaller. Like so. Okay, and then on top of that, we will actually use this cube to create a little, I guess, a simple tower. So this is going to, I'm just going to create an empty and I'm going to call it tower, basic tower. Basic tower. I'm going to set it to reset the position for now. I'm going to reset these guys' position as well. And I'm going to disable the map temporarily. So let's add the cylinder is going to be a base, and this is going to be the, the rotator. Now the rotator, let's move it up, like so. And let's make a new, no, actually let's add to the rotator one more thing. So what I'm going to do is I'm going to create a new object, and let's go with a another cylinder. I'm going to rotate it 90 degrees like so. And I'm going to make it way smaller than it currently is. Okay, maybe a little bigger. Well, zero. What would 0, 1 be? 0, 2. Oh, it's okay, like so. Maybe actually a little bit bigger. Like so. And let's increase the overall circle, like so. And then we will parent this to the rotator, and we will call it the gun spinner or something like that. Or we can make it into a cannon like looking thing. So this is the cannon hold, and then cannon inner. The cannon inner is going to be slightly smaller than the cannon outer. And now if we apply some colors, so let's just make a new cannon base. So I'll make the cannon base black, like so. Let's actually enable the map so you can see what our cannon tower is going to look like, and then get some colors based on that. And then this, we can make it purple, like so. And I guess the outer layer we will make as, yes, we can go with a a really dark color as well, like so. And then the inner, which is gonna slightly stick out, it's gonna be completely black using the same color as before. Now, with this, we have our basic tower. Now, what's going to rotate is the head here. Now, this might just be in the wrong position. Let's have a look. We'll see. Now, let's go into our prefabs folder and put our basic tower here for now. And let's drag it to the front. like so. Maybe it's actually still too big, but now we can grab the entire thing and shrink it down, like so. It looks better. I'm just going to apply the changes. And let's create a bullet. So we'll just create a sphere. Check the size. A little bit bigger, smaller. Just so it's believable. Yeah, it seems like 0.2 is a good metric to go with. And we'll give it, what kind of a color should I give it? Let's just give it a yellow color. So material, Canon, bullet. Canon bullet is going to be of a yellow color, like so. And we'll add it also to the prefabs, so we'll call it the Canon bullet. And we'll put it in here. So now there's several sets of scripts that we need to do. First, I'm going to create a new folder, and I'm going to call it tower. And in the tower, we will have a bullet script and a tower script. Now, the tower script will be attached to the tower, and the bullet script will be attached to the bullet. Now, in the enemy script, we will need to add a new script called enemy health, and that will be attached to the enemy prefab, like so. Let's just make sure all of the prefabs are updated. Now, if we go into and open all of our new pieces of code, there you go. So here in the enemy health, we will have to have reference to the enemy health. Well, we'll have to create our health. So what we'll do is we'll have a private, let's make it a float, and we're going to call it max health. And then we'll do private float current health. And that will be, and we'll actually use, will we use UI? I think so. So let's just go into using Unity engine.ui. Now, this will allow us to later have a health bar above the enemy. And so we'll do private image health bar, like so. So this is stores the maximum health of the enemy, stores the current health of the enemy, stores the reference to the health bar of the enemy, and we will make this serializable. So we can drag and drop the image, and we'll also set our max health to serializable, so we can assign how much health our enemy will have by default. On start, we will set our current health to be matching that of max health. And that's it for now. Actually, we will need one more function, which is called public void take damage. So this will enable our towers to damage our enemy. So we will actually take in a float of type damage. So what this does is a pass variable that removes health from the current health pool of the enemy. So what we'll do here is we'll do current health minus equal damage. And what we kind of want to do is current health. So if current health is smaller than 0, then we're just going to make current health equal to 0. And then we'll do this dot game object dot sect active false. No, we'll just destroy it actually for now because we've been destroying it so far. Destroy this dot game object. So that will automatically destroy the object once it has 0 health. And this method has to be called for it to happen. Okay, with this we don't need the enemy anytime soon. If we just click on the prefab enemy, there we go, we have our why do we have 2 of the same class? Okay, we have 2 of the same class attached. Let's just make this no for now. Okay, like so. And now for the tower will need to have, if we go into the tower, so our tower has to have a reference to the bullet. So serialize private game object bullet. Now this stores the reference to the bullet it owns, so we can instantiate it later on. And what else do we need to have reference to? The rotator, because it will rotate this based on where the enemies are. So what we'll need to have here is a private game object. I guess we can call it head rotator. Let's just call it rotator. Area that has to be rotated to face the enemy. Okay, like so. And now, so basically what we will be doing is we'll be checking for all of the enemies, and every time an enemy is within our range, we will just keep looking at them. And then we will implement the shooting mechanic later on top of that. But yeah. So if we now add, what are we doing? Yeah, so we have bullet, we have rotator. So to know which enemies to attack, we can use various techniques. Well, so first of all, we will have to make sure that we get a list of all enemies in our radius, and then we attack the closest one or any at that fact. So we need a private float radius, and we're just going to set it to 10 for now. And then we need private, and then game object transform, game object target. So how large the radius of the tower is, and then who is the target to shoot. So what this will basically do is we'll do if target is not known. Let's just do some quick testing. We'll do rotation is equal to vector 3 dot. I guess we can use. Well, is there a? Let's go into references. I know there is the ever so look at. How does look at work? I actually completely. I think it's a vector free lookup. Is it vector free lookup? Or is it quaternion lookup? Ah, it's. But there was 100% look at. Was it no? Well, am I wrong? I guess there's rotate towards. Well, let's try using rotate towards. How does that work? Vector free current target. So current is going to be what we are, and target is what we want. So let's just do this. Rotator, the transform the rotation is equal to, and then we'll do rotator target max radians delta. Can I? Would this not be good enough? It takes two floats. Let's have a look. Rotate towards. Oh, there's actually two different versions. So so it does it by speed. So it's gonna do it over time, I would assume, rather than snapping. Whereas what do we have here? Whereas quaternion don't rotate towards. How does? Okay, so this. Let's attempt to do this specific approach here and see how that works. Oh, too much. No, go away with the race. And then speed. So speed is how fast we rotate. Let's just keep it at 1. And let's see how this is going to work. So we only want this code to run if target is not null. Of course, we still haven't gotten around to calculating the closest target, which I'll do after I go to toilet. Okay, let's give this a go. Can I attach manually targets? I didn't even attach the rotator. No. Like this. Actually, let's do this. Remove this from the scene. Attach this here. Apply. Get rid of these guys. Oh, I still have the debug.log? No, I need to clear on play. Yeah, forget about the radius for now. Health bar. Yeah, forget about that. This needs to be serialized for testing. Okay, let's give this a go. Target. Okay, now basic tower, first enemy here. Okay, so this is actually exactly what we wanted to do. maybe the speed is slightly too slow. So we'll just add this as a variable now, and we'll do private float rotation speed. We're just gonna set it to 20 and change this to rotation speed like so. And then now a quick toilet break. Half an hour more and I'll finish this up. So let's try to quickly move on. Okay, so let's separate this code real quick. So this will be private void aiming. So this is our aiming logic. We're just going to put it all in one place. And now that we have our aiming logic, let's add the second logic, which is going to be about finding the closest target to our tower. So what we want to do now is, I guess we're just going to do, let's make actually a new private void find closest target. Let's call it that. And here we will, so we'll keep looking for our closest targets, and we'll do, I guess, a game object, and this will be targets. And this will be physics dot. Is it over? Is that the one I want to use? Overlap sphere. Yeah. So we'll do physics dot over sphere, and this will take this to transform the position. We'll take our radius and layer mask. So let's just add that in. So private game object enemy layer. Layer on which all enemies are found. So what this will do is it will only detect enemies on their layer. So if you go here, no, there we go. We have default. So I'll just add new layer called enemy. And this layer will be attached to our enemies prefab. So now, even if we have a different enemy that's not the red blob, they will all react to only this layer. That means they will not scan for every single thing there, only the guys with the enemy tag. Okay. Like so. So enemy layer. Now what is happening? Does it have to be an int? What? Can I do? Oh. Right. Glider. Layer. Silly me. I keep making everything an object, game object now. Yeah. So what this does is it sets our target. And now what we can do is we can check our closest target by doing a quick. So now we have every single target that's here stored, every single collider that's within the range. Now, then we'll do transform nearest target is equal to null, then float max. Let's see what I'm actually trying to do, and then we'll do so I'll have to do new, so I'll have to check every single target and then compare them with the nearest, all the nearest target. So what's going to happen here is we'll do targets dot length, and then if do I even need this section? Yeah, let's just think about it. So if vector free dot distance between, okay, quick thinking moment. So we currently don't have a nearest target. We check the distance between this target and that one. So we'll do this dot transform dot position, and then targets I dot transform dot position. And if it's smaller than max distance, which will be because it's infinity. So if it's smaller than that, then that will become our nearest target. And then nearest target will equal to targets I dot transform dot position, and max distance will become the distance that is will become basically this. So that should keep looping and giving us a new target that we'll keep looking for, right? And then just a quick one, if targets is higher than 0, because we can't call this code not length is higher than 0, and this of course checks if the target is not null, because we will be destroying them. Now, have we checked set radius? Yes, we did. Now, will this work? We will see. Enemy layer. Let's give it a go. Hello? No, it's not working. Programming 101 is working. Do they have to have a rigid body? Probably. Are they set to the layer? They are. Okay, let's just do some testing real quick. Targets. So targets is okay. So we now know for a fact that we do find the targets. So let's remove it out of the global variable. Well, this works. That's great. uh, so maximum distance. So we do run into the code. Wait, I did it the wrong way around. Did I not? Am I doing? Wait, that's right. That's right. Firstly, target is equal to nearest target. So silly. And then else target is equal to no. So, game up. Like so. Now it should work. Yeah. Oh, that was so silly. Oh, there you go. So it's a bit hectic with how it turns, and it's actually rotating the entire base. Whereas, oh yeah, I was only meant to rotate the rotator. So where do we rotate? Ah, there we go. Like so. Takes the top turret of the gun tower. Takes the top turret of the tower. Finds the nearest target to our turret. Now, interesting. It's interesting because you might think that this is actually wrong, but what is actually happening here is, or if we click on the rotator, we will see no, actually, let's go back. What behavior was it displaying before? Okay, so it actually catches it to it from the start. Target pop like so. Why are you fidgeting like this all of a sudden? Oh, crap. That's fine. There you go. Okay. So what we kind of need to do is scale down on that range. Is that, yeah, let's call it range, not radius. Radius is I actually want to see what's going to happen if there's no targets anymore. Yeah, so the tower correctly looks a target, and then it just stops moving. if there is no targets. Now we need to add shooting into the tower. So let's just add it in here. Void shoot, and that will be the last thing that we'll call an update. So shoot, just like the other one, will check if target is not null, because if we need to have a target to be able to shoot. Or do we actually make a new class for this? Let's just do it here for now. If anything, we can move it later. So let's just make a new header and then call it shooting, just to separate the logics apart. And in shooting, we will type in, what do we need? So we need to instantiate our bullet, which is right here. We also need to, I guess, have a delay between shooting, so private float time between, well, like rate of fire, and let's just set that to 2 for now. We'll add more variables as we go along. So what we essentially do is we instantiate the bullet, game object bullet as game object, and we'll put our bullet in. Do they both have the same name? Yes, they do. Bullet object, like so, and our bullet object will have its position. Okay, so this is what we missed now. We need we need a muzzle. So we need a point from which the bullet will instantiate. Point from which bullet spawns. Now if we click on our inner tanner and we create a empty game object, we set it out here, like so. We will call it muzzle. And let's change this to below a star. Let's change, pick a different color. Yeah, like so. And we attach the muzzle in our new point here. Update the prefab. Now what we'll do is we'll do bullet object transform the position is equal. Oh, let's just go set active. Yeah, no. Transform the position is equal to muzzle dot transform the position. So this puts our bullet at the same place as the muzzle. Handles the shooting logic. Now, what we'll do is to handle our rate of fire, we'll simply do rate of fire, and we will time elapse. So if time elapsed is smaller than, well, is greater than or equal to rate of fire, then we will perform this. And every time we do this, we set time elapsed to is equal to 0. And we will always do time elapsed. Like so. So we will constantly add time based on frames. We will constantly add to the elapsed time. If it's higher or equal to then our rate of fire, we then set it to 0 and we instantiate our bullet, which should fly towards the target. Now here we need to do some things in our bullet. So what we'll do is public void set bullet, we'll call it. Now a bullet will take in two things: a float damage and transform target, like so. So sets of bullet points instantiated. And in here, what we'll do is do bullet, new bullet, and then we'll make it equal to bullet object of get component bullet. So we're grabbing the component of that bullet, and then we can do bullet dot set bullet, and we will pass in the damage, which for now is just going to be just a variable like this, and we'll pass damage, and we'll also pass the target, which is target, like so. Now the transform. So this passes the bullet, spawns the bullet, and resets our fire. Now in the bullet class, what we will do is we will take this information over into our local data float. So we'll have our local damage, like so, and we'll just do damage is equal to damage. And we'll have our private float target, well, not target, transform. Target by default is going to be null, and again we'll just pass that over. Target is equal to target, like so. And then we'll create an update function, which we also need speed for the bullet. So private float bullet speed, and we can set that to 10. Now, what we're going to do is we'll make the bullet always follow the target. So instead of firing in a straight line, this is what actually most tower defenders do. They don't shoot to the location or predict the shots. They always just fly into the target. It's just that the bullets usually go really fast. There are some exceptions here and there, but it's just a general cheat to make it work like that, so it doesn't punish the player too much with how the game works. So here, if target is not null, then we handle all of our movement logic, else we actually just destroy the bullet. Destroy this game object. So if there is no target, we destroy it. If there is, we just do transform dot translate wisdom dot position plus equal to, is it plus equal to target times bullet speed. Is this what we're actually looking for? Am I doing it right or am I doing it wrong? Let's give this a try and see how this works. So handles the logic of the bullet moving. Conversion of the bullet's damage. Okay. Now, in theory, this should be all very nice. Oh, the bullets do actually spawn. But let's slow down the game a little bit. Let's reduce your speed to 0.7 for now, and the rate of fire, the speed of the bullet, make it slightly slower, and then where we have the tower, and then rate of fire is going to be 0.4 for now, so we fire way more often. Let's give this a try. Now let's inspect our tower. Oh. Well, would you look at that? The bullet flies in a very random direction. No, it's gonna be so that this is wrong. Minus. No. Yeah. Yeah. Let's increase the tower's radius real quick. Let's actually make some very serializables so we can play around with different game aspects. I said that, but I didn't change anything. Where's the bullet? I could just layer between, but that would be silly to do. Okay, let's just do it like this for now, because I'm almost out of time anyway. So what this will do is it will just make it equal to this. Now, what we kind of want to do is if transform dot position, well, if vector 3 dot distance is between our transform dot position and target dot transform dot position, and then we're going to make it smaller than 0.1f, 0.1f, then what we'll kind of do is the following. So if we remember, we created a take damage, so what we'll do is target dot get component enemy health dot take damage, and then we'll just put damage through like so. Okay, so what this will do is it will just equal our position to the target position as soon as we spawn, which should kill off the targets very quickly. Yeah. So if we look at the health, oh yeah, kind of another thing that we have to do is, so if this is, we'll do this, we also have to destroy this game object like so, so we don't have the same bullet damaging it over and over again in update. So now we should slowly start losing health if we look at the inspector. Or are we? Well, are we calling this before we call that? Okay, doesn't matter. Whatever. I am out of time. So this is where we're going to pick up later. So what we'll try to do is fix the bullet problem, make damage work, then add health bars as we started working on them, and then we can work on placing towers if there is time. That'll be it for this stream.